orthographic projection of lines. Actually, this is the final part of video. We will explain you how it is drawn in the paper, and we will derive the final conclusion from line inclined to both the plane. So the point, fixed point is drawn first with available data. So that is nothing but A dash and A. Next we will be, this is nothing but based on rule 1, the A dash has to be perpendicular line to XY. So now make line only inclined to HP. So theta, true inclination with HP will be drawn. So that is, as per our convention, it is B1 dash. So B1 will be located or deduced from projecting the respective projectors and extending the plan. AB1. B1 dash is located, B1 will be deduced. That is rule number 3. B1 dash B1, and because when true length is available in the front view, the other view will be parallel to XY. With that rule, we can deduce a line, a point B1. True length in the front view, top view will be parallel to XY. Now we know the true length and we know the inclination with this is the 3-dimensional view. Now we know the true length and we know the inclination with VP. So that is transferred in paper, and we used to name inclination to VP as B2. So we are drawing small AB2 plan of the line, and B2 dash will be deduced. So B2 is located and B2 dash will be deduced. So now we have drawn, using the rule 4, so now we have drawn 2 stages of line, individual stages, inclined to HP and inclined to VP. Now I will be achieving double inclination from B2 dash to B3. That is, inclined to VP is rotated in such a way that it makes double inclination. So inclined to VP, then inclined to HP. So I need where to stop that A dash B2 dash, because if it is a true length, true inclination can be given, but I am going to rotate A dash B2 dash as a projected length in a paper, so which is shortened length. So correspondingly, how much angle I have to rotate, I can find through the boundary plane only, because B3, the coordinate of a line which is inclined to both the plane, will be same whether you are achieving through B1 to B3 or B2 to B3. So that boundary planes are nothing but locus, B1 dash to B3 dash and B2 to B3. So once B1 dash is located, you can just like that draw a horizontal line parallel to XY, and B2 B3 also another horizontal line parallel to XY can be drawn. The projected B2 dash has to be stopped with that boundary plane or the locus B1 dash. So B2 dash is, so now I am moving from B2 to B2 dash to B3 dash. That is, inclined to VP line is made inclination with HP also. So that is B3 dash. Once B3 dash is located, I will just draw a line perpendicular to XY where it intersects the locus. So this is what stage 4 and 5 are complementary. You can draw 4 to 4 and then 5, or 5 and after that 4. So B3 dash is located, B3 will be on the same straight line, and where B2 will be when B2 dash B3 dash or B2 B3 will be a straight line. So with that idea I can deduce B3. With this I am completing all the data required, or I have completed the projection of a line inclined to both the plane. P3 is located. Now A dash to B3 dash is the final front view of a line inclined to both the plane, and AB3 is a top view of a line inclined to both the plane. The angle made with respect to xy, A dash B3 dash is alpha, AB3 is beta. So the problem is completed. That is, inclined to VP is made inclination to HP. VP then HP we have achieved. Now it can be checked by, this is beta, angle beta. Now it can be checked by drawing an arc from B1 to the locus of B2, B3. That is, line inclined to HP. This projection is taken to make a line inclined to VP. That is, A dash B2 dash is equal to A dash B3 dash. A dash B2 dash is a line inclined to VP only, the corresponding projection in the front view. A dash B3 dash is a line inclined to both the plane and its front view. Both front views are magnitudes are same. That's what we should deduce. This is the concept will be used in solving line inclined to both the plane. Now we'll be moving from AB1 to AB3. That means line inclined to HP is made inclination with VP also. So at that time it has to intersect with B3. Then only it is correct. That means 5 to 6, stage 5 to 6 or 4 to 5, both are complementary. This way we will be completing the problem. And now check that AB1, small AB1 is the plan or a line when inclined to HP. The plan or top view of the line when inclined to HP, magnitude is same when a line inclined to both the plane. That is AB3 and AB1 are magnitudes are same. So we can go by B2 dash to B3 dash, find the B3, or B1 to B3, find the B2 dash, find the B3 dash. That's it. Said that 4 and 5 are common. We can. So with this we are completing a projection of a line inclined to both the plane. Please keep in mind that it consists of 4 stages, one over the other are overlapped. From this we can come to a conclusion that in orthographic projection of straight line, projected length of a line in the other plane when it is parallel to one plane is same as when it is also inclined to both the plane. That is, now here you just watch AB2 is a line inclined to VP only. The corresponding projections are A dash B2 dash when it is inclined to VP only, and A dash B3 dash is when inclined to both the plane. So those two front view are equal in magnitude. Likewise, A dash B1 dash is a line inclined to HP only. The corresponding projections A B1 is when it is one plane, A B3 is when it is inclined to both the plane. But the magnitude of A B1 and A B3 are same.